Good afternoon, everyone, again. And I know one of the students is having a question.
Yeah, I actually was going to ask if there's any questions thus far because I know this is quite a lot to take in.
Okay, so I had a question there.
Sure.
We can hear you.
Okay, on pretending about the recycling part. So isn't recycling just extending the life cycle of a product just to discard it sometime later?
In some cases, yes, you can only recycle so much and you can only use so much recycled content depending on what is required for. Like if you're looking at certain plastics, you can only have that recycled for X amount of time, depending on the chemicals and the chemical compositions. You can only remelt it and whatever over and over, and you have to add a certain amount of virgin material with that to ensure that the product quality is of a certain standard. So it really depends on the situation. For example, if you're looking at the textiles industry, the textiles doesn't necessarily have also where they can right now they're working on things, and I think there are available technologies, but depends on which region you're in, where you can't do fiber to fiber. You can't produce a jeans and then the jeans goes back into a jeans itself, right? They're trying to improve that situation where you can use the cotton from the jeans and it goes back into that same specific. So it looks at again the strength of those fibers and whether it can actually sustain the recycling process for a period of time. So yes, the quality of the raw materials does deteriorate depending on what the raw material is. So for plastics, it could be that the integrity of it will change, and you have to add a certain amount of virgin material to ensure that you still have the product quality. So yeah, it can only be recycled so long. Thank you for the question. I'll continue because we don't have a lot of time, and I want to just give you some comfort that we will avail this to you, obviously, and I do go into a little bit of technical detail, but don't be. My aim is to impart as much of the life cycle approaches to you. So understand it's just a tool. We're not expecting you to become an expert. And but life cycle thinking is what you need to get away with, right? Is when you're working in a company one day, when you're doing an environmental assessment, when you're looking at a building, when you're looking at a brick, or when you're even looking at any types of service offering, that you have to have this complete idea of what happens and what are the impacts. And that is the way that you can make better decisions from a management perspective, and from a consumer perspective, from a raw material supplier, all of those things, right? So this is just a graphic that shows on the left-hand side. It shows from low to high the environmental impacts on this side, and then it shows on the x-axis the different raw material stages that we spoke about, not the raw material product life cycle stages. And what traditionally has happened that a lot of the emphasis has been placed on the manufacturing industry. Like I said, 80% of current efforts only cover 20% of the opportunities. If I go into a Coca-Cola factory or any of these soft drink factories, you can find that they've already optimized, they've tried to utilize as little energy as possible because it impacts their bottom line, right? These are costs that cuts down to their bottom line. That actually further downstream and upstream, there are opportunities where you can then look at building up better alliances with suppliers, having improved opportunities when it comes to using better chemicals, less hazardous chemicals, using limited resources, stability of the supply. And then also there's further downstream where you should look at the customer satisfaction and loyalty, improved brand image. If you've ever worn a Levi's done a full life cycle analysis, probably one of the first companies to do life cycle analysis, Levi's jeans. And what they realized was a lot of the impacts lay at the consumer side, how the consumer actually washes the jeans. uses a large amount of chemicals, water, and they would tell the consumers, this is how you need to wash it, or not wash it that often. You can wear your jeans 3, 4, 5 times instead of wearing it once or twice. You can put it in the freezer. You can also kill germs in that way. And this has built up brand loyalty, and it shows that the company and the brand is also more responsible. Right, and these are the different types of life cycle tools. There's design for sustainability, cleaner production and resource efficiency, sustainable transport. We'll speak about eco-labeling, sustainable lifestyles. I won't speak about all of these, right? Design for sustainability and sustainable resource management is all to do with life cycle analysis. These are all life cycle analysis falls under that, and eco-labeling I'll touch on at the end. Okay, also different way of looking at the different types of circular economy tools, which is cleaner production, as mentioned again, better service to extend lifespan, collect at end of life. So this was basically the graphic that shows that whole 9Rs ladder thing, but this is a graphic in a circular form, right? It's just a lot of these things come, and then you look at it and you see there's recycling, there's green products, minimizing waste. It all says the same thing, but it's different ways of stating it. What I want to show is that resource efficiency, if you're looking at energy efficiency, if you're going to a company and you're only looking at environment or whatever, and you have a management system, it touches on the different aspects of environment, economy, and society. But life cycle management covers all of those aspects, and that's the reason why it's important to look at life cycle thinking. This is a matrix that goes between 2 slides, and what I do is I will take a product and from a trying to identify from a very high level and a qualitative aspect for companies, what is the impacts of their product or service. And what we do is we will then map out all the different columns here, from raw materials, like I said, till end of life, and the aspects from materials intensity, energy intensity, health and toxicity, other social profitability, job creation. Again, you will get this graphic. This is one of the most important tools that I actually use, right? I will say, if I am producing a brick, for example, where would be my highest energy consumption? Would it be at when I get the sand for the brick and raw materials? It would actually be at the production of the brick. Why? Because they have all these kilns, which uses up to 1,000 degrees just to fire the bricks, to dry it out, and to form the bricks. And this actually takes a large amount of energy. What this would state is you can use a traffic light, which is green, yellow, and red, and you can say, oh, these are positive or negative impacts. It is a negative impact to have such high consumption. What can you do if you're looking at it from a high impact area? What would you actually do? So it literally maps out everything from, again, different aspects from each product. But also you can include social aspects. So it gives the company an idea, okay, what does it do in terms of labor? Is there policy on child labor? So here comes in the social impacts things. Does the client have policy on, again, child labor, policy on equal opportunities for staff, employment equity, staff development and training? All of those things are actually looked at, and you can then rate the company positively or negatively. You can use your own rating system for that. Again, it is a qualitative way of mapping out everything that happens with that specific product, right? And then you can then from there say, okay, it's not for the company to decide what to do. It's not for the company to say, I have no control, so what's the point of actually writing it down in here? Actually, it's not about what control you have or not. It's just highlighting those impacts. Many companies, for example, need to know what are the risks, what are the trends in their sector, to be able to identify any sorts of challenges or impacts that's going to happen in the next 5 to 10 years or something like that. Something that happened in terms of a social aspect for us in South Africa is the riots, in terms of, and strikes. It happens mostly in June, July time, or people will have like strikes for a lengthy period. This impacts the companies because they have downtime, there's no production happening, so there's profitability losses and stuff like that. Fuel levies and fuel, the cost of fuel will impact any country, any region. If it goes up, it impacts your commodities, it impacts everything. Right, and these are things that you don't have control over, but you do have to actually put it in there, because ultimately you can say, for example, if you're using a logistics company to transport your distribution, to look at where your companies are going to be able to transport things to your different products to different regions, you can then do proper route planning or work with your logistics company. So there are certain things that you can do, that you can have control over. And again, it gives us holistic view. You take a step back and you say, okay, what can I take responsibility with? What can I work with my stakeholders with? Can I then inform my consumers, civil society? Can I work with the residents or the NGOs? And again, it gives you this holistic view, but it unpacks the different impacts for the organization, and you can start looking at it from a sustainability aspect. And this is what industrial ecology is about. It's not only one aspect, is not only looking at where you're operating here, it's the different types of integrative environment that you operate in. Right. I won't tell you to do the hotspot matrix, as you can do on your own time. And this is the hotspot matrix that I was talking about. And you can grab it off here and just clear the tables, and then you can do it in your own time. It's not for you to do as homework. You won't be, not in my view, you won't be marked on that. Okay, and this is an example where we use textile sector hotspots and where there will be hotspots. And you can see that a lot of the hotspots actually lie in the raw material stage as well, under land use, social risk. And this is where they've used more of the bigger impacts are larger circles and the smaller impacts are low. So there's some chemical risks as well through the yarn manufacturing and weaving, but also at the raw material acquisition and processing and fiber preparation, and a little bit of chemicals also. Freshwater use mostly in the actual consumption, right? Not so much in the actual making of the raw materials, of the fibers, of the textiles, a little bit around dyeing, and mostly actually. So this is quite an interesting graphic, and this is something that you can do. And based on Google and things like that, but it is a qualitative way. You don't have to have exact numbers in this. Some examples that goes ahead is Durable Elegance for the Planet, so Lacoste, which is very popular brand name. What they did was also use life cycle thinking. So you can see a life cycle analysis, the lack of consistency. In 2020, Lacoste joined the Technical Secretariat of the Product Environmental Footprinting, which is basically the same as the LCA, but it is very similar process. However, it is supported by the European Commission to allow for comparative analysis between two different products. So there are some distinct differences, but overall the thinking and the methodologies are very similar. So Lacoste ultimately in 2019 hired a consulting firm to do the LCA for them, and this is what came up. These are the results for Lacoste. And the environmental performance you will see here for the textiles and footwear and leather goods. So they actually lumped it together, and you will find that in the supply chain was where was the highest impacts in terms of greenhouse gas emissions. For water consumption, it was again the supply chain, right? Which is basically up until where the product is being made. So everything from raw materials, the fibers for the different textiles. When it comes to footwear and leather, it's where the leather is being sourced, how it's being made, the tanning process itself for leather, and the actual products being made. So then the whole supply chain is the highest impact. So this then tells Lacoste, listen here, what am I actually going to do about it? So these results will then sit in the C-suite of that organization, and they would then discuss CEOs, CFOs, and say, what is it that these numbers are actually informing us? Okay, and then there's life cycle tools again. So these are, like I said, examples of the LCA, and then going into detail about what an LCA is. A life cycle analysis is basically an internationally recognized, so the ISO systems 14040, and in its communication on integrated policy. So it comes from the EU Commission, and there's a framework that has been developed through environmental footprints. It's basically calculated through the LCA. Okay. So why assess the full life cycle? And I think we've spoken about that extensively. We don't really need to go into detail, but we need to have that holistic view, right? And ultimately, when we get the results, it informs the decision makers to identify the hotspots. And this knowledge can then be used to develop strategies to reduce environmental burdens. And a little bit further on, we'll discuss around what types of strategies these are that you can improve to reduce your impacts. And LCA considers all relevant environmental impact categories in order to avoid inadvertently shifting burdens. What does that mean? That means that if you have one type of pollution, that if you do a full LCA, you will then understand that you might have a higher shift if you change opportunities or you change technologies. You might shift your burden to having maybe now not a water pollution, but now it is being disposed of to land or something like that. For example, wastewater treatment facilities, people do have more and more wastewater treatment happening on site at the manufacturing areas. What happens is they will now then produce a sludge, and then they actually have to dispose of the sludge, which sometimes is highly environmentally hazardous, and now it has to go to the landfill site. So what is actually causing the sludge? Now you have to unpack that and to understand that better. But are you now having you don't have the water pollution, you now have the solid sludge that goes to landfill site. Is this shifting burdens? Is this better or not? And this is where the thinking around LCA and life cycle thinking would then provide you with better opportunities, or what is the best opportunity. Additionally, omitting one or more life cycle stages can potentially lead to the selection have the highest impact based on the abbreviated analysis. But is associated with lowest burden when a full cradle to grave LCA is evaluated. So you can't just look at the facility for the product rather from cradle to gate. You have to look at it from right through up until the end. And this is the process. It has 4 stages in goal and scope, and then inventory analysis, as well as impact assessment and interpretation. So you're trying to identify what is the goal and scope of the process, and then also, what is the actual, is it from cradle to grave, cradle to gate? And then what is the point of doing the LCA? One of the LCAs that we've done for a company that actually produces alcoholic beverages. They wanted to identify whether it was best to go with recycled glass containers rather than having plastic containers. So we had to do the LCA between the two and to identify and prove to the management that it was better to use the recycled glass. And this is something that was done through the entire process, and they could then present this to the organization and say there is a lower environmental impact for using recycled glass. So then there's an inventory analysis, trying to collect data throughout the process, which is not the easiest. And then you look at the impact assessment through the CIMA Pro, different types of software that are available. There's also open LCA software available, and interpretation of this. For example, here there's different life cycle stages. This is just a block diagram. Again, we're using the textiles industry, materials production, manufacturing. This is the scope, right? It's manufacturing, what's happening there. And most of the time, you know what's happening in the manufacturing, but you don't know what's happening in the supply side of things. And then there's distribution and recycling. So that was the 4 stages. What's the use and how is it used, and what's the functional unit? So that is ultimately what is also forms part of the goal and scope, right? So typical functional units for bricks, for example, is 1 kilogram of fired brick or 1 metric ton of fired brick. So if you want to compare two bricks, you can't just say, okay, you can't compare apples with pears, right? You have to compare the same amount, and it has to have the same function. So if you're comparing paints, you will have the same amount of paint being used over a period of time. So again, you have to keep those metrics the same. So it's useful for comparing with other materials on a weight basis. And then also there's other areas where, or other aspects of functional unit where you can use piece-based. One standard fired brick works well for small scale. So you can just do an LCA that is not for comparative analysis. And then surface area based, you can also say 1 square meter of brick wall with defined thickness and mortar captures the actual surface produced, making it directly comparable with alternative walling systems. For example, you're now not comparing two bricks because obviously if you're saying, well, this building is made out of bricks and that building is made out of, what is this, gypsum board. Right, and that is also a material. Can you compare the two? How stable it is, the function of it, functionality, how long it will last, the fire, the retardant, repellent of it, other qualitative aspects of why a wall is there is to protect, to separate, and all sorts of things. So then we now have mapped out the company itself and the product and where the products come and go and whatever. It's just a simple block diagram. Now we actually have to collect data, right? And we spoke about the bricks, and you see here for each raw material stage, there's different types of inputs, and we identify it's clay, shale, sand, additives, chemicals, diesel, fuel, transportation, heat, energy, all of that. And then the outputs, how do you calculate those outputs? Where do you get that from? Most companies would actually have that internally. You can go to the engineer, things like that. And then approximate environmental load will then be related to that. This is something that's done technical, right? That's if you, when you do an LCA, you would then be able to relate it, but everything must be then related to the per ton of bricks, right? It's not for the entire turnover. It's not for millions of bricks being produced. It's only done for related to, so 50 to 100 kilograms of carbon monoxide or carbon dioxide is in the transportation stage for per ton of bricks. So this is also example of Procter and Gamble, which has a again life cycle inventory, which is the data collection stage, and they launch a project to perform the LCA of the laundry detergent Ariel, which is, I think you guys know of Ariel. And you can see how they've actually mapped it out. And this is a graphical way of actually mapping out. And the study was done in Belgium, and the life cycle inventory was done, this LCA was done way back in the 1990s. The analysis showed that more than 80% of the energy consumption occurs during the consumer use stage, and air and solid waste follow the same pattern, most of these being associated with the energy generation at the use stage, right? So more than 98% of the biological, which is the BOD, if you probably, you guys in environment will know what BOD is, however, is associated with the disposal stage even after accounting for removal during treatment. So what they've recommended was to actually have a cold wash. So these are how they then made a decision to say, okay, 80% of the energy consumption to reduce that, they tell people. So I use cold washes all the time. It's just something that we do, that I've done for many, many years. And it uses less electricity, and I don't even have a tumble dryer. I hang my washing out, and even if it rains, we have a little roof over here, and then we hang it inside, outside, and that's how we manage, because tumble dryers also use a large amount of electricity, right? So ultimately, how would you then look at the environmental impacts? And this is how it's presented in a graphical form usually. So when we go to companies, we'll say this is and you'll see here that on the right-hand side, there's the impact categories from global warming potential right up until particulate matter. and you'll find the different types of environmental impacts, and you'll find that particulate matter is mostly high in and global warming potential in the manufacturing and firing stages. And this is because, and this is kind of obvious, because where you're firing the brick, this is where you bring the product together to form, and there's lots of particulate matter going into the air. And you'll have obviously a global warming potential is the amount of CO2 that is related to your energy consumption. So this is a result that people expected, right? And this is also similar, showing similar results. And that is, this is a hotspot life cycle stages. So for the bricks itself, again, an example, manufacturing, firing, very high energy demand. So you can read that at your own time. Just take 2 seconds to read that quickly. And if there's any questions around that. So this is something that where the results were presented for each and every stage. And then what can be done? Does it make sense? So what they've actually done in terms of suggestions for improvement strategies for each and every stage from manufacturing right up until packaging, distribution, end of life, right? If you're using, for example, packaging distribution, they said the minor carbon dioxide from pellet and shrink wrap production, waste from plastic packaging, and then what they suggest is use recyclable or reusable packaging, optimizing load intensity to reduce trips. So many years ago, we actually had companies that would now, but for bricks, it's probably not really useful. I worked in an agro processing company, and they would produce breakfast cereal, and they produce it and put it in boxes, and they would shrink wrap it. And then there was this new technology that would actually give load stabilization without having to wrap it with tons and tons of plastic around it, and they would be able to transport it like that. And it saved them quite a bit of money on the shrink wrap itself, right? So there's lots and lots of options. So then, from the life cycle analysis and life cycle tools perspective, I've also included not only the LCAs, but also the product environmental footprint method, which then has 16 shows one single harmonized method to assess and communicate environmental impacts. And I mentioned that the LCA has different reasons. There's comparative reasons, there's reasons for just proving, okay, what is one product, environmental impacts, is it better to recycle? Is it better to keep the system as it is? So there's different reasons for doing an LCA, but for an environmental footprint, a product environmental footprint, the main reason for this is to compare two products, right? To be able to say that the product coming from Sri Lanka, whether they produce a shoe made with a rubber sole and leather top, that shoe produced in Sri Lanka versus the same shoe being produced in Namibia, right? Can you compare these two shoes? And that's why the product environmental footprint, and purely it looks at being used where ultimately the use phase is only in the EU. So this environmental footprint method was produced by the EU. And it uses similar types of methodologies, also looking at the goal and scope, and ultimately life cycle inventory, which is data collection, and then looking at how you can then do the environmental impacts analysis, and then trying to interpret that. And you'll see that this has 16 impact categories, from climate change, water use, land use, acidification, eutrophication. And this would mean a lot to you guys that are in the environmental field, and has the same, so it focuses purely on environment. It doesn't have any social impacts in this impact categories in it. Right, and this is how we actually did a product environmental footprint, and this was a dress manufactured by an Intex program that we ran in an SME in Kenya. And ultimately, you can see the acidification, EU particulate matter, but the highest impact category was actually water use for this product itself. And the most relevant processes was weight transported, distribution, and the cotton, actually. Right? And ultimately, this gave them an idea on what to do. for that specific product. What would they actually change about this product, how it's actually being made? So digital product passports is also another life cycle tool that is coming into effect for products itself. And digital product passports is a digital record of all the material components, environmental impact, footprint, and end-of-life options. So it not only includes environmental footprint, but also broader identification. It's sort of a tracing system of the products. And this is something that would become more and more popular, not only in the EU, but I think all over, right? It's like a digital ID. So it's not only barcoding system, but it can tell you exactly where this comes from, what raw materials being used, all of that information just by the QR codes that you can scan. So the European Union is currently rolling out DPP's requirements for construction products, so those different product categories, and under the EU circular economy. And then the benefits of linking LCA with DPPs rather, is transparency and trust. So you'll have lots of LCA that has already been done, but the LCAs will then provide more transparency when it comes to for the DPP. And then circular economy enablement, DPPs help track what materials are in buildings. So at the end of life, they can be reused or recycled. And then regulatory compliance, the EU is mandating DPPs for many construction products by the late 2020s. So this would become compulsory for these product categories. And having an LCA will obviously benefit these companies. And then it would enable companies to then become more innovative and efficient, right? So by improving, identifying hotspots and looking at improvements and knowing what types of actionable steps can be taken. So this is just to read for you. DPPs and LCAs, like we said, are complementary and will go hand in hand. And these are, again, life cycle thinking tools. Again, not only focusing on what's happening on one spot of the product itself, but happening throughout the product itself. Is more traceability. And it also enables much more transparency and credibility for that product and product categories and for the brand owners and companies producing it. Okay, and then discussion. So we can't do the discussion right now. We'll go on. Again, this is an example of a jeans, Jack and Jones. So I won't continue with that. Just to show that how companies are reporting, you'll see here's a carbon receipt and showing you carbon disclosure of exactly how much kilogram carbon dioxide equivalents are being used throughout the product itself. And this is becoming much more common if you're looking at the actual labels of when you buy a garment. There's some more examples here of eco-design smartphones, and you can choose, here is the results of the LCA. And again, the manufacturing side was the highest. And what was the sustainability design strategies? Is to design for durability and to design for sort of like a modular repair, upgrade, and recycling. All right. Office chair was another example that was taken. And then through the life cycle, again, materials and manufacturing was the highest. What was the improvement of sustainability strategies that can be made? Choose more sustainable materials. You can have recycled content. You can have, fibers that are more durable, designed for durability, and also much that can last much longer, and designed for repair and upgrade and recycling. So again, something of that can be noted if you are in this specific area. So eco labels, we have how many minutes left? This also goes hand in hand with life cycle analysis, because an eco label is something that life cycle analysis is not necessarily something that people produce in terms of showcasing. We've done a life cycle analysis, and you can get the report on our website. But an eco label is an actual label where you would say it's voluntary, it's again life cycle based, and it's third party verified. So someone else outside of the company, like a SABS or Bureau Standards, would actually approve this. And the company would then look at again the full life cycle. And you can see here that there are a few eco labels that is being mentioned. Um, Ones that are quite familiar probably through our area, our continent, is probably the FSC, Rainforest Alliance. Is also some fair trade. FSC is for Forest Stewardship Council, Marine Stewardship Council, seafood related. Energy Star ratings also looked at, where they will give you a plus plus grading of equipment, or rather appliances that's being used. And these eco labels are common, and you can go and buy a product. If you're buying a new washing machine, you can say, oh, this uses much, it's A plus plus certified, meaning it uses much, is much more efficient when it comes to energy usage versus the other washing machine. So these grading systems, people actually start considering. I won't go into the history. This is all South Africa related. But eco labels are goes hand in hand with life cycle analysis and life cycle thinking and tools, and it's something that's also on the forefront of companies when they want to export their products to different regions. And within Africa, we also have the African eco-labeling mechanism, which was started in the early 2000s under the AU African Union, and that is something that we can also refer back to. Okay, I'm done with this presentation. Are there any questions?
As a conclusion, I wanted us to do a very good brief conclusion.
Sure.
As a question. So considering some of the efforts that politicians, governments do put into to stop or to promote circular economy, to stop use of plastic and supply something that could replace plastic use. Do you see any future? Do you see a future where the world or Africa, let's actually start from Africa, do you see a footprint that is being made that shows hope that it could move into a green economy, a circular economy where we don't have to worry, where we are not at a high risk stage or level?
Yeah. No, I think we definitely have. I mean, there's lots of initiatives by governments. So there's a lot of things around policies in green economy and integrating all of the sustainable development goals. And I think we just need to find those very good examples, like I said, to sort of showcase the positive aspects of our area. And I mentioned, like, for example, the thing around Ghana, and then trying to sort of hold more of the of the supply chain when it comes to cocoa. That is a very good example where they take responsibility of it, and obviously benefits the country and the people of that country, right? It creates more jobs instead of outsourcing and contracting, and then we eat their chocolate and stuff like that. So ultimately, there is a definitely a way forward for us when it comes to green economy. There's many, many programs and policies that's in place. There's a elimination. So United Nations work with different countries around, for example, eliminating single-use plastics. There's a huge program around that. There's a program around global framework on chemicals. There's so many different programs that African countries are involved in. And you just have to watch and follow whatever sector you're part of. There is clear case studies and best available technologies and techniques for those sectors as well. And I think definitely there's more positive aspects coming forward, and people are taking more responsibility, not just waiting on government to then bring in new policies, but they're doing it out of their own, seeing the benefit of what sustainability actually can do for them, because there's a myth that says sustainability is expensive. It's not expensive. If you want to reduce your water, electricity, it will obviously you'll pay less if you are more efficient, right? And you'll have better turnover. So that makes sense for rands and cents or money wise for any company to do that.
Okay. Thank you. Thank you so much. Thank you so much. And I want to appreciate for your time and taking extra time. I know we're supposed to finish at 5:30, but I want to deeply, on behalf of Share School in Africa, appreciate your experience you just shared with us. I think I'm looking forward to invite you again. This is a long topic that could take many
Yeah.
hours. And if you allow us in the future, we can host another talk on industrial ecology. Thank you so much for your time.